And if we label the information that was provided, QT bisects angle PTR. So if we label that, we see that relationship. And then QT is perpendicular to PR, so we have the same relationship here. And now, it was a common mistake as I've come by and seen people working through this to think that this first statement means that angles 1 and 2 are equal. And you can't say that angles 1 and 2 are equal by definition of bisect. That tells us that these two angles up above are equal to each other. So I'll make that statement first, PTQ and RTQ are congruent angles by definition of bisect. Okay, so this gives us a pair of angles in our proofs that are equal. And then angles 1 and 2, we can go through the same two steps to show that those are equal. I'm going to use the equation form. Angle 1 equals 90 degrees, angle 2 equals 90 degrees by definition of bisect or of perpendicular. Therefore, since two things are equal to the same thing, they must be equal to each other. So angle 1 and 2 have to be equal. That's transitive property or substitution. So this gives us a second pair of angles that are equal. So now all we need is any other pair of corresponding sides, because either ASA or AAS will work for congruence. The easy pair to see is this shared pair of sides QT once again. So if we just make the statement that QT is equal to itself, that gives us our third pair of elements. And that's reflexive property. And then once again, we now have three pair of corresponding elements that are congruent. That's enough. It fits one of the patterns. And the pattern that it fits, when we look at the information, we have two angles and the side in between. So even though I've written these as A and then S, the pattern that's fulfilled in the picture is two angles, the side in between, so ASA is the justification.